Hi, this is Miss G. So we're going to talk about the polarity of molecules. So you need your notes to do this. So we are on page 7 of your notes. And you will also need your blue paper that says geometry of shapes. So if we're polar, what we're going to look for is an unequal distribution of electrons around the central atom. So that could be due to bond types, atoms, or lone pairs. When I talk about lone pairs, what I'm talking about is, let's say we have NH3. So lone pairs are what's on the central atom. It can be on the top and it can be on the top and bottom. So that's called a lone pair. So that will automatically make it polar if we see something like that. So examples are CH3Cl. So if we're talking about that, carbon with the 3 hydrogens, and Cl. Let's erase this. Let's start this again. So we have the 3 hydrogens and the Cl. Because there's a different element there, atom, than hydrogen, that would be considered polar. So another example would be water. These are called lone pairs. It automatically bends it and also makes it polar. Let's see, HNO2. Let's see how that works. So I guess we can figure this out. So 1 plus 12 is 13, 18 divided by 2 is 9 pairs. So we've used up 3, we have 6 left. All right. 1 and 5 is 6, 6 and 12 is 18 divided by 2, which is 9. So we've used up 3 pairs, we have 6 left. So, and then we've used up everything. So if I take one of these pairs and put it over here, so because hydrogen and oxygen are different, that's going to make it polar. All right. So if it's nonpolar, we're looking for total equal distribution. Examples like hydrogen, silicon tetrahydride. So notice that it's totally equal all around it. There's not a different atom. Erase that. Let's see, I think this ends up to look like this. It's even on both sides, so again, it's nonpolar. All right, so we're just going to take each one by itself and decide if it's polar or nonpolar. So we've said this is linear, it's straight across. Because these are 2 different atoms, we're going to say it's polar. So this has 4 around it. This is tetrahedral. Because it's totally even all around, it's going to be nonpolar. So these are called lone pairs. So that automatically we say it's bent. It will also make it polar. So those lone pairs automatically make it polar. So this is linear. We can't do anything except go straight across. And because they're equal on both sides, we're going to say they're non-polar. So again, we have what we call lone pair that bends it. And then it's polar because that automatically makes it polar. So this is equal on all sides. So we're going to say it's non-polar. This is actually trigonal planar because we have no lone pairs. All right. So notice that these are different. So it is linear because there is nothing on my central atom. But we're going to say it's polar because it's different, the different distribution of electrons. This is equal. Oops. So it's non-polar. And we're going to say it's tetrahedral. There's 4. So again, it's tetrahedral and it's even, so it's the non-polar.